All right, so this video is going to go over page 16 through 17 in your work and energy packets. We're going to be talking about kinetic energy. So kinetic energy is the energy due to an object's motion. Okay, so instead of going through this next sentence, it's basically going to explain your equation, which is kinetic energy equals 1/2 mass times velocity squared. Okay, so you got to have mass and you got to have velocity in order to have kinetic energy, because kinetic literally means movement. If you're not moving, therefore you have no kinetic energy. So the kinetic energy is directly proportional to the mass and directly proportional to velocity squared. So what that means is, if I were to increase my mass, let's say I doubled my mass, okay, so what's going to happen to my kinetic energy is it's going to go up as well by the same amount. Okay, so that's what directly proportional means. Now, since the equation has 1/2 mv squared, okay, if velocity goes up, kinetic energy is going to go up too, but not by the exact amount. So let's look at an example. Let's say my velocity goes up and we're going to double it. Okay, that means your kinetic energy is going to go by double squared since velocity is squared. So 2 squared would be 4. So that means your kinetic energy actually goes up by 4. Okay, let's try another one. If our velocity went up by 3, okay, so instead of going up by 3, it's going to go up by 3 squared. So now your kinetic energy went up by a value of 9. Okay, so just by increasing that velocity, it's going to start exponentially increasing your kinetic energy. Okay, if you went the other way, okay, so let's say my velocity went down. So let's say we divided by 2. Okay, that means your kinetic energy is going to go down by 2 squared. Okay, so you're going to go down by 1/4. Okay, so just be careful with this squared right here. Okay, because we can ask questions is, if I double velocity, how's it going to affect kinetic energy? If I reduce mass, how's that going to affect kinetic energy? So just make sure you pay attention to those relationships. So we're going to start off simple. What is the kinetic energy of a 12 kilogram rock? Okay, so I have mass rolling at 3 meters per second. There's your velocity. So we're just going to plug in. So KE equals 1/2 my mass, which is 12, and my velocity is 3, and that's squared. And you're going to get a value of 54, and then in order to do work, it requires energy, so we're going to keep the units the same as work, so it's going to be joules. Okay, so your answer would be 54 joules. Now it says, what is the speed of a 170-gram baseball? Okay, so I need to be in kilograms, so I'm going to divide this by 1,000. Okay, so that ends up being 0.170, so mass equals 0.170 kilograms. Okay, when it has a kinetic energy of 110 joules, so I gave you KE right here. So we're going to plug in. So 110 equals 1/2 your mass, 0.170, and V squared. So if you do your calculations, you come out to V squared equals 1294.12. Okay, don't forget there's a squared there. In order to get rid of that, you're going to have to square root both sides in order to get rid of this square. So you get a final velocity of 35.97 meters per second. There's your answer there. So moving on to the next page, we're going to talk about the work energy theorem. Okay, so we just talked about work and energy have the same units because work needs energy. Okay, so work is equal to change in energy. And since we're talking about it, kinetic energy is it's energy. It's just kinetic, means movement. Okay, so you can say work is equal to change in kinetic energy. So your equation would basically look like this. Is work equals 1/2 mv final squared, so this would be your final kinetic energy, minus 1/2 mv initial squared. So that is your initial kinetic energy. So if you ever need a reminder, remember it is always final minus initial. Okay, so if you need help with that, F comes before I in the alphabet, so it's always final minus initial. So it says how much work was done when a 5,700 kilogram truck, so we're looking for work. I have a mass, speeds up from 50 kilometers per hour to 75 kilometers per hour. So I cannot have these, so what I'm going to do is I'm going to divide by 3.6 to fix these. Okay, and we're going to get a new velocity, so my VI is going to come out to be 13.89 meters per second. And my final velocity is going to come out to be 20.83 meters per second. So in order to speed up, you have to do work. Okay, so think about if you're running on a track, you're jogging, and then you want to go up to sprinting, you're going to use energy. You're going to be working to get up to that speed. So work equals that change in kinetic energy. So your final kinetic energy would be 1/2 your mass, which is 5,700, times your final velocity squared, so 20.83 squared, minus your initial kinetic energy. So 1/2, your mass is still 5,700, and your initial velocity is 13.89, and that's squared as well. So you're going to get a big value here, which is okay. We're talking about a very heavy truck that's speeding up. Okay, so you're going to get 686,726.88 joules. Okay, what is the stopping force? So you're looking for a force on a 30 kilogram object. You have a mass that started at 10 meters per second, so VI, and stopped. There's your VF at a distance of 15 meters. Okay, so you have distance here. Now, there's a couple ways you could do this, and you can pick whichever you want to. You have enough to do Daffy T, okay, and then you would solve for A, and then do the whole F equals MA thing. You can do that if you want to. Okay, so this way, I'm just going to keep going the way we're kind of going. So remember, work equals change in kinetic energy. Well, remember, work equals force times distance. So we can take that force times distance and set it equal to 1/2 mv final squared minus 1/2 mv initial squared. So my force, I don't know. My distance, oh no, actually, so yeah, we're looking for force. My distance is 15 equals 1/2 mv final squared, which I don't know why I'm doing that part, is because if you're coming to a stop, remember this whole thing goes to 0 because your final velocity is 0, so it's going to be 0 minus 1/2 mass, which is going to be 30, and then VI would be 10, and that's squared. So you get F times 15 equals negative 1,500, and so you get a stopping force of negative 100 newtons. And that'll end that one.